Okay guys, this is the question that's about mechanics for the paper 2. So the first thing is, again, I've kind of tried to highlight the paper where I've made some of my kind of thoughts at the beginning, and I'll go over each question as we go through them. So the first one is saying an air is propelled vertically downwards with a speed of v. The aircraft hovers motionless. Okay, if we're saying motionless, that means it has a constant velocity. Okay, above the ground. A package is suspended. The mass of the aircraft, so the mass of this one is 0.95 kilograms, and the combination of the mass of the package and the script ring is 0.45. Sometimes people like annotate them on the picture as well. If that helps you guys, you can also do things like that. And then the next one is the mass of the air pushed downwards by the blade in 1 second is 1.7 kilograms. That means here we've got 1.7 kilograms per second being moved, okay? So it's just really important when as soon as I read that in 1 second, I'm just going to write that next to it, because it means probably later they're going to give me something with time that I need to use. So when I see that per second and they haven't just said the mass of the air, okay, I need to make sure I'm remembering that per second. So right, usually it means there's something coming up where I need to use it. So the first one is state the resultant force on the aircraft when it's hovering. Well, I've already said it's motionless, it's constant velocity, so it must be 0. There's also a state equation, it wasn't a calculator or anything, so it must just be a simple 1 mark. So it's 0, it's motionless, it has a constant velocity, no resultant force, but you don't actually need to write any of that. You just need to write 0. Exclamation mark is not needed. And it says outline by reference to Newton's third law how the upward lift force is achieved. Now, a lot of you, I found with this, were getting the right idea, but you weren't as great with your wording for this. Now, in this case, again, you can state Newton's third law, that's absolutely fine. Okay, it's only 2 marks. So the things that they were looking for was this. The blades are exerting a downward force, and they did specify in the mark scheme that you must say downward. You need to give the directions of these forces. So the blades are pushing down on the air, okay? Now, in this case, they're pushing on the air below them. I had a few people saying on the earth. The blades aren't pushing on the earth, they're pushing on the air, okay? So also, you got to think about your pairing and what you're talking about. So the blade exert a downward force on the air. Therefore, the air would exert a force that is equal in size, but opposite in direction up against the blade. Okay, again, if you've referenced Newton's third law, this will also help in here. I just simply tried to combine my Newton's third law in my second statement for my second mark there. All right, but that's hopefully a few things. The things I found people were missing was the force, and some people were saying ground rather than saying air, or they just stated Newton's third law and didn't tell me what the interaction was in this case. All right, so just making sure you include those things. It then says determine velocity. State your answer to an appropriate number of significant figures. Well, in this case, we have 2 significant figures. 2 significant figures. 2 significant figures. You therefore must use 2 significant figures. The IB go with you must use the significant figures that are being asked within the question. So in this case, we know that the lift force has to equal weight. Okay, we were talking about them being in equilibrium, so they must be equal. Okay, so F, okay, is the change of momentum in 1 second. All right, so we can also use our equation, our F is equal to mv over t. So in this case, I have 1.7, remember, over time, so that carries me back to this little bit over here. Remember, so change in momentum is my mass change in multiplied by v. So at this point I have 1.7 v. Okay, now in this case, that's my lift weight. So that's 1.7 v is equal to my mg. So in this case, I just simply added these together. So 0.95 plus 0.45. Okay, both for the total mass of that, 9.81. So 1.7 v is equal to 1.4 times 9.81. Gave me this, it gave me 2 significant figures, 8.1 meters per second. Just remember here, again, F, I don't know if I drew out the equation, but F is equal to the change in momentum over the change in time. That's our mv minus our mu over delta t, m over t. Okay, kilograms per second, that's where that 1.7 kilograms per second. That's the big thing that a lot of people missed up here. People just started giving me masses as 1.7. in this place. That was another thing that I saw, and I've had one people like just leaving it completely blank. The worst thing that you can do is leave it completely blank. At least give me something to give me some speed, because you were going to need it for the next one. All right, so even if you're not sure, make up a value. You can use it in your next parts. All right, you can get error carried forwards used for that. The next one then said calculate the power transferred by the aircraft. So transferred to the air by the aircraft. So power, work done over time. Well, it's kinetic energy, so half mv squared over t. That's m over t is popping out there again. Okay, that 1.7, remember. So in this case, I've got a half times 1.7 times the velocity I've just calculated from above, so 8.1, which is equal to 56 watts. A lot of you tried to do this using the power is equal to FV, P is equal to FV equation, which is correct, you can use it. But just remember, this is average velocity, okay? So in this case, you'd have to do 8.1 over 2 to give me the average there, which would give you 56 watts. A few of you making a little mistake with that bit. 1E generally, as well, a lot of people got this incorrect. Now, at this point, we say the package and the string are now released and fall to the ground. The lift force of the aircraft remains unchanged. Calculate the initial acceleration of the aircraft. Well, before, they were hovering, right? So we had lift and we had weight being equal, but now we've taken away that little mass of the packet. Okay, so I've got rid of that W there. So vertical force is lift minus weight now, okay, because weight is going to be smaller. Now in this case, all right, essentially because I've taken off my lift force earlier, okay, we knew was equal to like the mg, which was my 0.7, let's say 0.95 and my 0.45. Now we've got just, in this case, I've minus the weight component, so I'm now just left with 0.45, lots of it, times 9.81, which is equal to 4.4 newtons. Again, at this point, we want to calculate the acceleration, so F is equal to ma. A is equal to F over m, so 4.4 divided by the mass. Now this is the mass of what I'm left with, which is my 0.95 of the aircraft, which is, that's terrible writing, let's just say 4.6 meters per second squared. So that last little one there, again, a few people here just went straight into just putting this A equals F over m and just using just the lift force. You weren't remembering to subtract the weight in there as well. So for example, here the lift was 0.45 plus my 0.95. The weight now is like 0.95 only, so the cancel and cancel, that left me with the 4.5. Okay, so that's what 0.45 there, times 9.81. Okay, and then a lot of people again forgot then sometimes with that mass here, again it's still just 0.95. A lot of people would forgetting to either subtract the weight and leaving with just the 0.45 at the top, or people were forgetting here as well that this was just going to be 0.95, which makes sense. It's a little bit of a tricky one to think about. So in this case, remember I might just write this out a little bit more just at the bottom. So lift minus weight. Okay, so that would be 0.45 plus 0.95 g minus 0.95 g. Well, in that case, that just leaves me with 0.45 g, so my 9.81 up there. And then here, your mass, because we got rid of the package, we're now just left with this. All right, so I hope that makes sense, that question. If not, let me know and we can go